Okay, welcome. So we're going a little bit out of order due to changes in our schedule, but it doesn't really matter too much because all we're doing is continuing what we've been working with, and that is using tests to test different series for convergence or divergence. And the tests we're going to talk about today are the ratio and the root tests. So let's go through the ratio test first. If we've got a series of non-zero terms, if the limit as that a sub n series converges, it converges if a sub n plus 1 over a sub n is less than 1, diverges if it's greater than 1, and it's actually inconclusive if it equals 1. This is kind of a fun test, so let's see it in action, see how that works. So we're asked to determine if the following series converge or diverge. So here we have the sum as n goes from 1 to infinity of 2 to the n over n factorial. Well, to do the ratio test, and just a side note here, the ratio test is really good when you have factorials and or exponential work. Okay, so I'll just make a little note about that here. So factorials and exponentials. And exponentials. Good for that. Good for x factorials and exponentials. Okay, so back to our ratio test. So here we've got this, we've got a factorial, and we've got an exponential. So it is good to probably use the ratio test. Now, before I use the ratio test, I should say what's going to happen if I use my nth term test. Well, I'm just going to get like infinity over infinity, basically, right? So it's not really going to give me anything. So that's why I can use my ratio test now. So I'm going to rewrite this as the limit. I'll do it over here. The limit as n approaches infinity of, and my n plus 1, I'm just going to rewrite this as 2 to the n plus 1 over n plus 1 factorial. And then all of that is over 2 to the n over n factorial. Okay, so we know that we can rewrite that as the limit as n approaches infinity of 2 to the n plus 1 over n plus 1 factorial times, and this should still be an absolute value, times the reciprocal, right? N factorial over 2 to the n. And now I can actually rewrite that again. I've got the limit as n approaches infinity of, I'm going to rewrite 2 to the n plus 1 as 2 times 2 to the n, right? And this is times n factorial. Okay? And this is over, I'm going to rewrite n plus 1 times n factorial. I'm going to stop. And then this is times 2 to the n. Now, hopefully you can see here that we've got a lot that's going to cross out here. So we've got, these are going to cross out, these are going to cross out. So now I just have the limit as n approaches infinity of 2 over n plus 1. Well, that equals 0, right? And that's less than 1. Therefore, so the series converges by the ratio test. Isn't that kind of fun? Okay, I like this one. There's a lot of algebra involved. So let's do letter B. The sum from 1 to infinity of n squared, 3 to the n plus 1 over 2 to the n. If I use the nth term test for divergence, I don't really get anything. So now I'm going to use my, actually, wait a minute here. What do I get? If I do the nth term test, I would get n squared times 3 to the n plus 1 over 2 to the n. That would go to infinity, so actually it would diverge by the nth term test, but let's do the ratio test anyway. All right, so we're going to have the limit as n approaches infinity of, big absolute value there, n plus 1 to the 2, what am I writing here? 1 second. Okay, I don't know why I got confused. It's n plus 1 squared times 3 to the n plus 2, right? N plus 1 is 2, over 2 to the n plus 1 times 2 to the n over n squared times 3 to the n plus 1. Okay, I just multiplied by the reciprocal from the get-go there. So this is equal to the limit as n approaches infinity of, well, this n plus 1, we're going to just have 1 there, so we're going to have 3 times this n plus 1 squared and n squared. Well, those aren't really going to cancel out, are they? So we're going to have n plus 1 squared, but 2n would cancel out, so, and that's just going to be over 2, but my n squared is still there, right? Okay, so if I find this limit, I don't really need to expand this out. I think you can kind of see here, you'd have an n squared, so it would just be your leading coefficients, and the leading coefficients there are going to be equal to 3 halves. 3 halves is greater than 1, therefore, so the series diverges by the ratio test. Okay. All right, let's do one more. Here, the sum from 1 to infinity of n plus 1 factorial over 3 to the n. Well, that would actually also diverge by the nth term test, right? So you'd have infinity over like slower infinity, but anyway, it would still diverge. But let's do the ratio test again, just to get our practice here. So we're going to take the limit as n approaches infinity of, we're going to end up having n plus 2 factorial over 3 to the n plus 1 times 3 to the n over n plus 1 factorial. So I can rewrite that as the limit from as n goes to infinity of n plus 2 times n plus 1 factorial over 3 times 3 to the n times 3 to the n over n plus 1 factorial. Oops, why did I do that? Should be an absolute value there. These are going to cancel out. These are going to cancel out. So now we're left with the limit as n approaches infinity of n plus 2 over 3, and that's just going to be infinity, right? So the series diverges, because of course infinity is greater than 1, the series diverges by the ratio test. Okay, so now very similar to the ratio test, we have what's called the root test. The root test states if we have a series and the root of that absolute, the nth root of the absolute value of that, it converges if it's less than 1, it diverges if it's greater than 1, it's inconclusive if it equals 1, okay? So we just have 2 quick examples here to go through. The sum from 1 to infinity of e to the 2n over n to the n. Well, let's write this. If this whole thing can be written as a power of n, the root test is really good to use. So I think we can rewrite this as the sum from n equals 1 to infinity of e squared over n all to the n power. So because I've been able to rewrite that whole thing as a power of n, I can use the root test. So I'm going to take the limit as n approaches infinity of the nth root of e squared over n to the nth power, and that's equal to the limit as n approaches infinity of course, and all of this, these, how do I want to say it? It's all going to cancel out, kind of, you know? So it's all just going to become e squared over n, right? The limit of this is just going to be like e squared over infinity. It's going to be 0. That's less than 1. So the series converges by the root test. All right, let's do one more here. This one's already written in terms of to the nth power for us. So I'll take the limit as n approaches infinity of the nth root of 3n plus 4 over 2n to the nth. So that's equal to the limit as n approaches infinity of 3n plus 4 over 2n, which is going to become 3 halves, which is greater than 1. So the series diverges by the root test. 2 kind of fun tests that you learned today. If you have any questions, leave them in the comments, and I hope to talk to you soon. Bye.